Hi, my name is Michael King. This is the second video, and we're going to be looking at measuring risk. This is section 8.3, or parts of it, from both Cleary and Rikita. Okay, recall that we're in the present. There's going to be the past, which we call ex post. There's going to be the future, which we call ex ante. This video is going to focus on the past, ex post risk. Now let's go back and look at the same example to see what the measure of risk would be for this investment. Notice that we had the $1 that we invested today. It grew to $1.23 at the end of 5 years, but it wasn't a straight path. It went up in the year 1 by 20%, down by 8, down by 6, up by 14, up by only 4. As you recall, the total return was 23%. The arithmetic mean was 4.8% per annum, and the geometric mean was 4.2%. How do we go about measuring the risk of this investment? Well, we would use a measure from probability called standard deviation, and the standard deviation in this case is 12.2%. Now, what does that mean? Well, this is what we call the historical risk, the realized risk, or the ex post risk, and it measures the dispersion of the returns relative to the mean of the distribution. Okay? In this case, it's relative to the arithmetic mean of the distribution. The more variable the returns, the greater the risk. That's what normally the relationship we would expect to see in finance. Okay? Notice that the arithmetic mean of 4.8%, you add 12.2, and it is something close to, it's obviously not 20%, but it's above. And if you subtract 12.2, well, you're down below, but you're not as low as 8%. That's because the one standard deviation on either side will not capture the full distribution. So the measure of ex post risk is standard deviation, which is sometimes referred to by its Greek letter, sigma. It's calculated by using this formula down below where you see sigma is equal to the square root of the sum of deviations in an individual year relative to the average year, which is the arithmetic mean, squared, divided by n minus 1 observations. Okay, that can be written by, as shown on the right. You may also hear the word variance thrown around. Variance is simply squared standard deviation, so it is sigma squared. So ex post risk is measured using standard deviation, and we're going to sometimes call this uncertainty, variability, or volatility. So here's an example from before. We see our case where we buy the stock at $1, we sell it at $1.23, and it goes up, down, down, up, up. Okay. How would you calculate the standard deviation if you had to do it by hand, not using a calculator or Excel? Well, you would have to find the arithmetic mean, which is 4.8%. You would have to take the difference in any given year relative to that. So in year 1, 20% minus 4.8% is 15.2. You would have to square that difference. And if you do that each year and then sum them up, you would then have to take that and you would have to divide it by n minus 1 observations, which is 5 minus 1 or 4. You now have everything that's under the square root, so then you take the square root of that, and as a percent, it turns out to be 12.2%. Another measure that you can use to standardize this sigma or the standard deviation across two different stocks is to take the standard deviation and divide it by the arithmetic mean of returns. And this is called the coefficient of variation. It kind of gives you a measure of how much variation there is per unit of return. Stock A has a standard deviation of 15%, but a mean return of 7. Stock B has a standard deviation of 12% per annum and a mean return of 5%. So which one's better? Well, you can't judge it simply by the absolute size of the returns because one is more volatile than the other. So if you were to use the coefficient of variation, you would see that stock A has 2.14 and stock B has 2.4. The lower is better, so we want stock A. So if we were to look at ex post returns and risk measures for different securities, we would expect that stocks would be highest and government bonds would be lowest. Why? Well, risk and return. Take a look at this table below, which shows returns from 1938 to 2018 for different securities in Canada. Government of Canada bills, which are shorter than 1 year maturity, Government of Canada bonds, which are up to 30 years maturity, Canadian stocks, and also US stocks as measured in Canadian dollars. Notice that the annual arithmetic mean and the annual geometric mean is increasing as you go from bills to bonds to stocks, Canadian stocks to US stocks. Notice also that the risk of these investments is going up. So there is not a free ride. We see that the standard deviation goes from 3.9% for Treasury bills to over 17% for US stocks. Does this make sense? Yes, it does. We see that higher risk is associated with higher return.